So this is Anne-Sophie Crunchant, a field primatologist and wildlife conservationist. She's recently defended a PhD last year at Liverpool John Moores University in the UK, where she evaluated passive acoustic monitoring as a tool for chimpanzee detection, density estimation, and localization. She's worked in the field across Central, Western, and Eastern Africa, living for extended periods in some of the most remote parts of the continent. Wow, something I think we'd all quite like to do. During this time in the field, she studied wild populations of chimpanzees, bonobos, and gorillas. I spent hundreds of hours following individuals of each species, as well as innovating remote monitoring techniques using camera traps and acoustic monitoring to sense eastern chimpanzee and bonobos. Her talk is Acoustically Assessing Apes, Chimpanzee Conservation with Passive Acoustic Monitoring. So I shall pass you over to Anne-Sophie.
Hi, I am Anne-Sophie, and today I'm going to talk to you about chimpanzees and how we can use passive acoustic monitoring for their conservation. Chimpanzees are present in Africa, from southern Senegal to western Tanzania and Uganda. They inhabit various habitats, from rainforest to savanna woodland. Chimpanzee populations are severely fragmented, and they are listed as endangered on the IUCN Red List. They are mostly threatened by habitat loss and degradation, poaching, and human-linked infectious diseases. Rapid monitoring is needed to evaluate the intensity of these threats and establish conservation actions, but also to assess population trends. For my research, I've been working in Tanzania, Eastern Africa, and more specifically at the Isa Valley. On the map here, in red is the chimpanzee distribution, and in green are the national parks. It's estimated that there are only around 2,500 chimpanzees left in Tanzania, and 75% of the population is present outside of national parks. Chimpanzees range at low density and over large areas. They are semi-arboreal, and they spend 50 to 60% of their time underground, and they are elusive. Because they are very shy, it's very difficult to see them without a very long habituation process. Monitoring methods rely thus mostly on non-invasive and indirect indices. One of these indirect indices are chimpanzee vocalizations. Their calls can travel hundreds of meters, so chimpanzees are an ideal candidate for passive acoustic monitoring. Passive acoustic monitoring, which I will call PAM later, is a method that uses a unit composed of one or several microphones and records any taxa that produces acoustic signals. Here is an example of a chimpanzee call called a panthoot. Chimpanzees are a gregarious species and form small parties that change in size and composition during the day. Because they move through a relatively large territory and are often hundreds of meters apart, they rely mostly on vocal communication to tell others about footing trees, predator presence, or to coordinate movement within and between parties. In this presentation, I will focus on three axes. First, I will show how PAM and a statistical method called occupancy modeling are efficient for detecting chimpanzees. After detecting a species, another parameter that is important for conservationists is to know how many individuals are present in an area. I will show how we can estimate chimpanzee density with PAM at the condition we know the call rate, which is the number of calls an individual produces per unit of time. Lastly, another study I wanted to present is about an acoustic localization system we developed to study chimpanzee spatiotemporal movement. Usually, conservationists rely mostly on light transects and camera trapping to monitor populations. Even though PAM is more and more being used, only a few studies used PAM with chimpanzees. So with colleagues, we wanted to compare camera trap and PAM to detect chimpanzees. With occupancy modeling, we evaluated the efficacy of each method, and in short, occupancy models use detection, non-detection data from multiple visits of a given area to infer the probability of species presence, which shows the estimated number of sampling days needed to establish chimpanzee absence as a measure of efficacy. Which means with how many days of deployment can we be sure a species is absent? We deployed 52 camera traps and 12 song meters 2 from Wildlife Acoustic for 9 months in the Issa Valley. The results show that with only 10 or 15 days of PAM deployment, depending on the season, we could be sure at 95% that chimpanzees were absent. This is 5 times faster than with the camera traps. This study also showed that chimpanzee detectability varies over season, as shown on the figure. So for early or late dry season or early or late wet season. And this difference is likely due to seasonal differences in social grouping and ranging patterns. So this information is important for conservationists who can target their studies, for instance, during seasons a species is the most vocal. After detecting a species, another parameter that is important to conservationists is abundance or density. We evaluated the possibility of estimating chimpanzee density with PAM using an acoustic spatial capture approach. For this, we need to identify calls of the target species without error, but we do not need individual identification. And we also need to know the caller location. So how can we do that? So we can use information on the locations of detectors that did or not detect a call. We can use the time difference of arrival of the sound, but for that this requires time synchronization of the sensors, and we can also use the received signal strength. This statistical method gives a call density, which is the number of calls per unit of area. But the parameter we want to know is like how many, not how many calls, but how many individuals. So this method, so for this, we need to convert the call density into animal density, and we need the call rate for that. So with focal follows, we evaluated the chimpanzee call rates in a study that has recently been published in PERJ. With the camera traps, we evaluated 2 statistical methods, distance sampling and capture, and we also included results from a previous study with line transects and the density obtained from direct observations. The density obtained with acoustic spatial capture data was lower compared to direct observations and with the camera trap data. We suspect that the occurrence of chorusing when multiple animals vocalize simultaneously likely contributed to the lower estimates with acoustic spatial capture. But research is only at the beginning, so we have a good hope that this could be solved. Last study I wanted to present is about chimpanzee localization. So this time we did not use song meter 2, but an array of 4 custom-made sensors that we deployed around the perimeter of the valley that we knew it was important for the chimpanzees when we collected the data. Each sensor, like shown on the picture, so it was comprised of a microphone unit integrated with a nanocomputer Raspberry Pi, a GPS unit, 3 solar panels, and 2 batteries. Acoustic localization has already been presented in a previous webinar with Daminil, but in short, it uses the time difference of arrival of sounds to multiple time synchronized sensors to identify the sound origin location following triangulation. To quantify the error and precision of the system, we conducted a playback study. So we broadcasted a tonal sequence at different locations and at different time of the day, and also to validate the system with calls from wild chimpanzees, we conducted chimpanzee focal follows. With the playbacks, we found that the mean localization error was 27 meters, and chimpanzees were localizable with an error of 52 meters. And we also found that sounds were better localized when the temperature and the wind were low. And now just a short field anecdote. So when I was in the field and when we deployed the localization system, we would hear almost every night for a week or so lion rumbles. But we were like, oh, okay, it's fine. They're quite far from camp and we don't need to worry. But on the audio files of the acoustic array, we heard this. Which are chimpanzees who seem a bit scared. And a lion. So the system localized a lion less than 1 kilometer away from camp and very close to where the chimpanzees nested that night. So I thought, well, maybe I made a mistake when I localized the sound like with the system. But then we went to get the SD card from some camera traps in the field and we saw this. So we had the proof that, well, a lion was quite close. So in summary, PAM is great for chimpanzee conservation, and well, it's more efficient than camera trapping for their detection. We can use it to estimate density, and we can localize chimpanzees with quite a high accuracy. But, and there is always some but, the initial equipment can be costly. Even though the price is decreasing, it can be an obstacle to some old NGOs. Storing the audio files can also be problematic because PAM generates terabytes of files. And for now, there is no chimpanzee call detector, so manual data analyses are extremely time-consuming. But all of these disadvantages can be compensated by its advantages. So for instance, the high detection range means that we do not need to deploy a lot of acoustic sensors. This is a non-invasive method that do not require a lot of field labor. And as seen earlier, we can locate chimpanzees with a high precision. All of this is also valid for other loud calling species, like wolves, gibbons, and well, all other loud calling species. So my main message for this presentation is use PAM because it's great. Here are 2 reviews that we made about new technologies, including acoustic sensors. One which is more specifically for primate conservation, and well, it has been published in International Journal of Primatology. And the other one is a book, more general about conservation technology. Well, thank you very much for listening, and yeah, thank you.
Thank you very much, Anne-Sophie. That was fantastic as well. And I'd love hearing about things I know so little about. And yeah, chimps, I know absolutely nothing about chimpanzees. So thank you so much. Questions are coming in. So if you're okay to answer a few, that would be great. I'm going to think up some as well, because I've got some in the back of my mind, which I've not formulated yet. But here's the first one. Do chimpanzees show interest or make any attempt to manipulate the recorders in any way? Do they try to program or break them?
Yeah, I was quite lucky because no, I didn't have any problem with that. They didn't show any interest at all. So yeah, the recorders were safe. But I had some problem with the other system. And because it was on the ground, so like some other animals, I don't know which one, but they just grabbed the thing and broke everything. But other than that, yeah.
See, I've only had one experience with putting a recorder out near primates, and it lasted an hour, and then both my microphones were eaten, and you can hear the point where they're tearing. They had a fight over my microphones. But anyway, did you run into any particular practical problems using passive acoustics in the field? And how did the recorders cope with the temperature and the moisture? Basically, is there any advice for other people planning similar work?
So my main issue was mostly power, like to keep the recordings like that didn't last long enough. But like for the temperature and the humidity, I didn't really have a problem there because it's a savanna woodland habitat. So it was quite dry, so I didn't have any problem with the humidity. So that was quite good.
Excellent. I think we've mentioned this before. We had two webinars ago, and it was looking at all the problems that you might face out in the field, and one is obviously humidity. But I think one of the bigger issues is the changes in humidity. And being in the UK, apparently we have a huge fluctuating range of humidity. It's dry one day and then really humid the next, and so I think we get a lot of problems here. I think if it's always humid or always dry, I think you're okay. It's when it fluctuates.
Yeah.
How does one determine how to set up the recording or the recorded distribution for the best results? Is there a best geometric pattern with optimal overlap for coverage?
Well, I think it will depend on the species you are interested in. For instance, the chimpanzees, their calls can travel up to 1 kilometer. So if you want a call to be recorded on multiple sensors, you would maybe like put the sensors like maybe 500 meters away, one each. And otherwise, yeah, it really depends on the question you want to answer, I would say. Yeah, maybe it's best to like have recorders on each side, for instance, of a valley, or to be able to maximize the area and minimizing the risk of not recording any sounds.
Yeah, no, that's good advice. Good advice. Could you please talk a bit more about the analysis involved in triangulating the sound of chimps?
Okay, so I had 4 sensors, and so I looked at so for each sensor, like at the same time, I determined the time of arrival of the call at each sensor, and then I used like a software called Sound Finder. Well, so you enter like the GPS location of each sensors, you put the time difference for each call, and then it calculates the localization.
Okay, excellent. Could you tell if it would be possible to build up a library of the acoustic repertoire of chimps using passive acoustic monitors?
Yeah, probably, and I think that would be great to do. And because one thing we missed is like a call detector, and I mean that would be really useful to have this. And yeah, so yeah, I think it's possible. Yeah.
And I take it from that you'd be able to look at behavioural patterns of each group as they kind of move around.
The thing you might miss actually is like the closest call, because well, the chimps would need to be very close to the sensor to be recorded. So yeah.
Fantastic talk. Do you have any ideas of how to infer the number of individuals in a chorus of pant hoots?
No, I think this is really complicated, and I don't think it's possible to do it. We might have an idea, but we might have an idea like how many individuals, but to know precisely how many, it's impossible. I mean, yeah. You
can get it to I've got a lot or I've got a small number. Yeah. That's it. Yeah,
I would say so. Yeah.
What are the other parameters besides call rate that you can extract from the audio to monitor wild populations of chimps?
So I didn't extract the call rate from the passive acoustics. So I used a focal follow. So I was following the chimpanzees to get this value. Otherwise, I don't know, like, I mean, we can use occupancy modeling like to know more about the distribution of the species, like in following the season and the pattern and all of these kind of things. Yeah, there's plenty of things we can do with.
Yeah, well, I think that's the one thing, is that once you've recorded it, you can reanalyze that data over and over again, and you can go back to it and everything else. Once you've got it there, it's yours to play with, basically. Yeah. So, do you think it would be possible to make? Do you think it would be possible to make individual classifications using a combination of passive recorders and camera traps? I think that's to. I think what they're saying there is to. Would you be able to tell individuals from the combination of the calls and the information from the camera traps, basically?
Well, I think you will need to be very lucky to get the calls and the videos from the camera trap at the same time to know like which individual is calling. So I would say it's not impossible, but it will not be the best solution to do. Yeah, I think the best solution is to follow the individuals and to record the calls. Yeah, I don't think it's possible. But
another thank you for a really interesting talk. What were some of the toughest challenges you faced when you were collecting acoustic data? Did you have to habituate the groups you were monitoring beforehand?
The group was already in the habituation process, so I didn't have to habituate it completely. But when I started, it was not fully habituated, so that's why PAM was really useful. But when I collected data on the call rate, for instance, they were fully habituated, so it was much better. But but one other thing with PAM is that you can probably use it to like help habituating chimpanzees with the localization system, for instance. If you know, if you know where the chimpanzees are, you can go, and then it would help to habituate chimpanzees.
Oh yeah, sorry. I thought I'd ask you a question. It's just that it all started with thank you. So thank you for the nice talk. You see, so that's what I assume PAM must generate huge amounts of data. Do you identify the chimp calls by analysing recordings manually, or are you automating it?
No, I did everything manually, but so I use spectrograms. So I scan through all the spectrograms manually using Raven. But yeah, so this is a huge amount of time to do that. Yeah. So if someone can find a call detector, I will be very happy. But we might hear more like with the next talk. But yeah, so
excellent. Were the chimps clearly hesitant to inhabit areas where the camera traps were? Were they suspicious of the camera traps, I suppose?
Well, the camera traps, they were there for a while already. So I don't think there was, when I connected the CD, there was no problem at all. And well, chimpanzees are quite curious, but I don't think there was any problem with that.
And I've got 2 more questions that I want to make sure I've get through. Is it possible to discriminate calls from adults and juveniles using acoustic data?
Yeah, I would think it's possible, because when we hear them in the field, we are able to do that. I mean, when, for instance, if I follow a chimp, I would be able to say like, oh, okay, it's an adult and or juvenile. Yeah. So I think with PAM, we would be able to do that as well. Yeah.
And actually, there's another question snuck in, so I'm going to ask you 2 more. How did you confirm the 500-meter buffer around each acoustic sensor?
So we know that chimp call can travel up to 1 kilometer. So I just based on that, at 500 meters, we are sure that it should pick up the call. Yeah, that's basically that.
Have you ever considered to study sleeping behavior in nests using vocalizations?
Yes, why not? I mean, we would need to record like at night, and with the localization system, actually, we could localize the nest, and we could do something with that. Yeah, I think that would be very cool to do.
Chimpanzee snoring. It's just what you want. Hours and hours of going through data of chimpanzee snoring. Fantastic.
Yeah. But well, chimpanzee, they vocalize quite a lot at night. So yeah, that's
excellent. Well, Anne-Sophie, thank you so much for your talk. It was wonderful. Thank you so much for answering all those questions. I'm sure there will be other questions appearing in the Q&A. So if there are any, please, if you'd be willing to answer them, that would be absolutely wonderful as well. But thanks again. Big round of applause again from the world that we can't see, but I'm assuming everyone's staying here, so they must have appreciated something. So I think, yes, thank you once again for that.
Thank you. Thank you very much.